we have this problem where we have to find the derivative of a function, and after that we will find the values where the tangent line to the function is horizontal. First, we'll take derivative. This is a quotient, so we use the quotient rule. So in general, the derivative using the quotient rule, derivative of a quotient, so that is the quotient rule, and we're going to use that. So the top in this example is x. The bottom is 5x minus 7 to the fifth power. Right. So derivative of the top derivative of x is 1. Now we take derivative of 5x minus 7 to the fifth power. We have to use the chain rule for this function. So to use the chain rule, we ignore what is inside the parentheses. Right. So it doesn't matter what inside the parentheses, we take derivative of it. Something to the fifth power, so we have 5 parentheses to the fourth power. Doesn't matter what inside the parentheses, but the chain rule, very important. We have to take derivative of what inside the parentheses. Now what inside the parentheses actually doesn't matter. Now we just copy it, 5x minus 7, 5x minus 7. Right. First we have 5 times 5x minus 7 to the fourth power. I just copy that from the previous line. Now we'll take derivative of 5x minus 7, which is 5, and multiply 5 times 5x minus 7 to the 4 powers times 5 again. We can multiply the 5 and the 5 here, give us 25, 5x minus 7 to the 4th power. Right. Now we have everything to substitute into the quotient rule. The top derivative of the top is 1, and then the bottom 5x minus 7 to the 5th power. Subtract the top is x, and then times the derivative of the bottom, which is 25, 5x minus 7 to the 4th power. I should put the 4th inside the bracket. That's what we should have. Right? All of that over the bottom square. And then we have to square that. Right. Now we multiply the top and then simplify. We have 5x minus 7 to the 5th power. Subtract. We can multiply the 25 and x together. So in this one we have the minus the x, and then the 25. We're not going to multiply with 5x to the 7 to the 4th power because that is the power term. We're not going to mess with that. We just have 25x, 5x minus 7 to the 4th power. And then at the bottom, 5x minus 7 to the 5th power, and then square power to another power. We will multiply the 5 and the 2. So we have 5x minus 7 to the 10th power. Right. Now, uh, all of them have 5x minus 7. Now, I will factor what we can on the top. Right. So the top, we have 5x minus 7 to the 4th power. And this also have 5x minus 7, but to the 5th power. So one of term have 5 factors, one term have 4. So we can take out 4 of them. So we'll factor out and we write 5x minus 7 to the 4th power. Once again, the first term have 5 factors of 5x minus 7. We can factor 4 of them out. The second term have 4 factors of 5x minus 7. We can factor all 4 of them out. When we have the common factor of 5x minus 7 to the 4th power, we determine what inside. Once again, the first term have 5x minus 7 to the 5th, meaning it has 5 factor of 5x minus 7. Since we factor out 4 of them, one of them is left. Right. Uh, yeah, just leave it like that. And then the second term, we have 4 factors of 5x minus 7. We factor out completely, so we have nothing left but the 25x. The bottom, we have 5x minus 7 to the 10 power. Right. Now, we still have 5x minus 7 to the 4th power. 5x minus 7 to the 4th power. Now, inside the bracket, we have 5x minus 25x, so that minus 20x. And then minus 7. All of that over 5x minus 7 to the 10 power. Now the top has 4 factors of 5x minus 7. The bottom has 10 factors of 5x minus 7. So we cancel all 4 factors on the top. If we cancel 4 factors of the bottom, we're going to have 6 left. Right. So cancel 5x minus 7 to the 4th power, top and bottom. On the top, we only have negative 20x minus 7. And the bottom, we have 5x minus 7 to the 6th power. And that is the derivative of the function. Now, the derivative of the function is also the slope of the tangent line. And that we're going to use in the next part of the problem. And once again, this is the derivative, which is also the slope of the tangent line. Now, on the next part of the problem, we want to find the values of x that makes the tangent line horizontal. The horizontal line has the slope equal to 0, meaning the derivative is equal to 0. So let me write this. Right. Tangent line is horizontal, meaning the derivative equal to 0. Because the derivative is the slope of the tangent line, and the slope of a horizontal line is equal to 0. Right. So we just have the derivative negative 20x minus 7 over 5x minus 7 to the 6th power equal to 0. Now, uh, this rational function equal to 0, uh, the bottom cannot be equal to 0, because if 5x minus 7 equal to 0, uh, divide by 0 is undefined. But if we want the fraction to be equal to 0, the top is going to be equal to 0. Just say the top equal to 0. Notice, because we completely simplify the derivative, so we know that the top and bottom has no common factor. So if the top is 0, the bottom cannot equal to 0. Now, the top equal to 0, then the whole ratio will be equal to 0. The rest should be simple. Negative 20x minus 7 equal to 0. Add 7 on both sides. Negative 20x equal to 7. And then we divide by negative 20 on both sides. We have x equal negative 7 over 20. And that's what we have for this problem.